Alright, so this is a video to go over the homework for tonight. I'm not going to do every single question because I do want to leave some for the kids to try. But, so, I am going to do a couple to, make sure, that they know how to do it and to give an idea of how to help out. So, A and B are a little simpler. Okay, so for example, they can be split into 3 different types of rectangles and find the area of all 3, add them together. B, we can find the area of the entire square and then these 2 smaller squares, and then just subtract the 2 small squares from the large square, and we got our answer. Okay, so find the area of the large blue square, and then find the area of this one, and subtract. So big minus little, and you got your answer. Now, for C, I'm going to be a little more detailed, because this is a harder question. So we're going to break C up. And one of the easiest ways to do that is here. And I am going to apologize now. My handwriting is going to be a little worse than usual because, as the kids know, I didn't have my glasses today. And so on top of not feeling well, it's a little off. So we've got a rectangle down here at the bottom. And so that's 1, 2, 3, 4, 5, 6. And 1, 2, well, 2 times 6, this area is 12. So we're going to have 12 plus. Well, there's a couple ways we can do this top one, and probably the easiest way is if we split it here. Well, now I can take this triangle rather, and move it around. Well, it's 2 down. And 1, 2, 3 across. 1, 2, 3 across. And so now this space is this space. And so now I've got a rectangle there that is 2 down and 3 across. Well, 2 times 3 is 6. And so 12 plus 6 is 18. And so that's the area of the shaded section. Okay? Now it doesn't matter if we had moved it to that side or if we had moved it over to this side, it's the same thing. Okay? Now, we could have made it more complicated and broken it into, smaller triangles and more rectangles and everything. We could have found the area, and again, this is a more complicated thing, and not something you have to do, but we could have done this, turn this into a rectangle, and then said, well, this rectangle and this triangle go together, and find the area of the unshaded and subtract it off from the rectangle. But that's needlessly complicated. And so it's just easier to leave it with this. Okay? Now, this is where having some tracing paper does come in handy so that you can see that you can move this and fit it over here. And I do have tracing paper in the classroom if you want to use it. Just ask, and you're welcome to it. Okay? And so we can do that. Okay. And now for these questions, it's the same idea. Okay? It's just they're not on the grid like A, B, and C are. So I personally would split this one right here and find the area of this square and find the area of this rectangle and add them together. For B, I'd find the area of the big blue rectangle and subtract the area of the little rectangle. So then you find the area of this little rectangle. And to get your answer, so find the area of the big and rectangle, find the area of the little rectangle, and get your answer. And C is pretty much the same thing. Big minus little. So find the area of the big thing, find the area of the little thing, and subtract. Now D is like what we did up here. Okay. Now, personally, I would love to just show you the formula for an area of a triangle right now, but we're not there yet. So, we're going to take this and move it around. Well, this is 8 across. So, 8 across goes to here. 5 down is 5 down. And so it fits perfectly. And so now we've got this shaded section to match that shaded section. And so we find the area. And so that's 5 times 8, which is just 40 centimeters squared. And that's our answer. Okay, all done. We're done. Yay! Okay. And so now we go to our next page. 2 plots of land have very different shapes. Noah said that both plots of lands have the same area. Do you agree? Explain. So, now, this is a rectangle, this isn't, and the one on the right, B, is not. Well, remember the engaged today. The engaged today had us look at a square and a square cut out of, but with the same size here. Okay? And so this piece that was cut out was the same size as this. And yes, I know my drawing is very bad. So let's try that again. And so this, my drawing still isn't great, sorry, but this was the same size as this. And so if I took this piece and put it back, then they were the same size. So we take a look and see. If I take this and I put it here, is it the same size? Okay, and so that's how you have to answer that question. It's just like the engage. And I'll leave the explanation part up to you. And for our last question. All right, let's zoom in so that I can actually read it. A homeowner is deciding on the size of tiles to use to fully tile a rectangular wall in her bathroom that is 80 by 40. The tiles are squares and come in 3 side lengths. Sorry, I know I'm reading really slow and monotone, and I apologize for that. It's really, as I said, I don't have my glasses, so it's really hard to read. So the side lengths are 8 inches, 4 inches, and 2 inches. All right, so we have to decide if we agree with each statement about the tiles and explain our reasoning. So regardless of the tile size she chooses, she will need the same number of tiles. So this means that no matter whether she chooses 8, 4, or 2, she'll need the same amount of tiles to fill this in. Okay, so for A, I would say sketch a diagram. Okay, I always suggest sketching a diagram, so it's kind of a helpful thing to do. So now I know it's a rectangle. I sketched a square. Oops, I'm bad. So 80 and 40. Well, if we choose 8, well, then that means we'll need 10. One, 2, 3, 4, 5. That's 8, 9, 10. And so that's 10 to go up. And to get to 40, we'll need 5. Well, so I used 8 and 5. Well, 8 times 5 is 40 tiles. Well, now, if I use the 4-inch tiles, well, 4 goes into 80 20 times. Four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And 4 goes into 40 10 times. That's 5, 6, 8, 9, 10. I am seeing double on my tablet, and I don't like it. And so that means I use 10 and 20, and so 10 times 20 is 200. And so then if I used 2-inch tablets, 2-inch tiles, I would have to do even more, because 2 goes into 80 40 times, so I'd have to go 40 by 20, which would be 800. Well, 40, 200, and 800 are not the same. And so, no. Well, agree or disagree, so disagree. because eight, 4, and 2 go into 80 and 40 different amounts. Let's try spelling that word again. And so therefore we would need a different amount of tiles. Okay. Regardless of the size she chooses, the area of the wall that is being tiled is the same. Well, yeah, I agree with that. Agree. The wall size isn't changing. The tile size is. Okay, she will need two 2-inch tiles to cover the same area as one 4-inch tile. Well, a 4-inch tile is 4 by 4. Well, 4 times 4 is 16. And so, a 2-inch tile would be 2 by 2. And so 2 by 2. So will two 2-inch tiles cover the entire thing? She will need 4 4-inch tiles to cover the same area as one 8-inch tile. Well, one 8-inch tile. Well, then we look at a 4-inch tile. Well, that's half. So 4 and 4. 4 and 4. 4 and 4. 4 and 4. So 1, 2, 3, 4. So yeah. So disagree, agree. And so if she chooses the 8-inch tile, she will need a quarter as many as the 2-inch tile. Well, 40 over 800. Well, 40 goes into 40 one time, 40 goes into 800, 40 goes into 80 two times, and 0 times, so it's 1/20th. 1/20th isn't 1/4, so disagree. And so I will leave the explanations of C and D up to you. Okay, hopefully that is helpful. I don't want to do the entire assignment for you, but hopefully that's enough to get you started and help you out. All right, good luck, and I'll see everybody tomorrow.